All right, so in this video, we're going to discuss angle pairs. The essential questions that we have for today are how do we identify angle pairs and how do we use angle pairs to solve measures? So first angle pair that we have are complementary angles. By the definition, when two or more angles sum to 90 degrees. Now, as a quick reminder, how do you know an angle is 90 degrees? Right? You're going to look for that box. So if you see an angle, you're looking for this box. When you see that box, you know you're dealing with a 90-degree angle. Then with complementary angles, generally you might see something like another angle inside of there, such as this. Now, that's not always going to happen, but it is a good general rule to look out for. The next angle pair we have are supplementary angles, right? When two or more angles sum to 180 degrees. What we're looking for here is we're looking for a straight angle, right? So straight angles, remember, are just essentially lines, right? So look for straight angles. Now, again, remember, this is a guideline. That's not always going to be the case that they're going to be right next to each other, okay? They may be separated, right? So again, let's take a look at this first example here. It says two angles below are complementary. So always make sure that you read that first part because it will give us some sort of hint about what is the relationship that we're gonna deal with to help us solve for this missing measure. So in this case, it says the two angles are complementary, and then the measure of angle GHI is x degrees. What is x? So if we know that they're complementary, right? Complementary to us means adds to 90 degrees. So that means the two angles, the 34-degree angle plus the x angle, should add up to be 90. That's going to be our setup here. So then when we solve, right, I'm going to subtract 34 from both sides. X turns out to be. All right, so let's take a look at this next example. There's some typos here. We got to fix them up before we start this guy. This should be let's just eliminate this one and write in the new one. So that should be 7r plus 6. And we got to put those parentheses and a degree symbol around. So taking a look at this problem, we know that the two angles below are complementary. So again, I see complementary. Complementary tells me, or I should be thinking, adds to 90, right? Add to 90 degrees. And we got to find the measure of each angle. Let's write out what we know. We know that they add up to be 90, the angles. Now that I got that equation written out, I'm going to substitute what I know, right? So this angle is 7r plus 6. Angle GHI is 8r plus 9. Right? And we're going to solve for r here. So r turns out to be 5. But we're not done in this problem because they're asking us to find the measure of each angle. So the measure of angle LKJ is 7 times 5 plus 6, which turns out to be 41. And the measure of angle GHI is 8 times 5 plus 9. So our two answers, measure of angle LKJ is 41, and the measure of angle GHI is 49. And you can double check, 41 plus 49 does add up to be 90. So we've done this correctly. Taking a look at the third example, two angles below are supplementary. If the measure of angle MNO is 78, what's the measure of angle PQR? So again, so we see this keyword here, supplementary. When we see this geometry word, we want to say, or we want to think, add to 180. So the measure of angle MNO plus the measure of angle PQR should add up to be 180. Now we know MNO is 78. Right? Solving, I'm going to subtract 78 from both sides. The measure of angle PQR is 102 degrees. Next example, what's the measure of two congruent supplementary angles? Okay, so congruent means equals, right? That one might be a new term for some of us. We're not familiar. All right, congruent you want to think is equal. They're not exactly the same. I mean, congruent in geometry means something even more than equal. But for the case of measurements, equality is good enough. Supplementary again means adds to 180. So we should be thinking add to 180. So we've got two angles, they add up to 180, and we know those two angles are equal. So we may not know what they are, but we know whatever those angles are, we'll call them x. They have to add up to 180. Well, we got an equation, we can solve this. So each angle is 90 degrees. Two more terms, adjacent angles, two angles that have the same vertex and share a side and do not overlap. Right? So adjacent angles, a picture similar to this one. This angle here is adjacent to this angle. So if I were to write that out, two angles that are adjacent and whose non-common sides form a straight angle is what's called a linear pair. So linear pairs are adjacent angles, something to always remember. So it's not in this definition, but it's implied. So linear pairs are adjacent angles. So something to remember there. Now, when you see adjacent or linear pairs, you'll see something like this. So we have two angles, right? So those two angles are a linear pair, and we can see that they make, right, the sides that they don't have in common make a straight angle. Angle MGT and angle TGY are a linear pair. This leads us to a linear pair postulate. All right, we're going to want to abbreviate this as LPP. So you don't want to forget this one. You're going to end up using this a lot later in the school year. All right, so it's abbreviated as LPP. Two angles are a linear pair, then they are supplementary. So example 5, what is the value of each angle? So when I take a look at this one here, right, I can see that the two angles add up to be this straight angle, right? So I've got this angle right here, 7q minus 46, and I've got this angle over here, 3q plus 6, and they add up to be a straight angle, so they're a linear pair. Angle 7q minus 46 plus 3q plus 6 equals 180. And the reason why we can do that is because they're a linear pair. We've got the straight angle, and these two angles add up to be that straight angle. So cleaning up our algebra, we've got 10 So Q equals 22. And then we substitute back in our Q to figure out our missing measures here. So measure of angle ABD is 7 times 22 subtract 46. I'm going to take out my calculator here. I get 108. And then for my other angle, I get 72. Verify and double check. 108 plus 72 does add up to be 180, so we're okay. Example 6, are angles CDA and DAB a linear pair? Are they supplementary? So first off, if it helps, I'd like to highlight these angles. CDA. So are they a linear pair? Well, I would say no, because although they share a side, right, here in purple, they don't share a corner. Okay? So they are not a linear pair. Because they don't share a side and corner. Are they supplementary? Well, supplementary doesn't look for position. It just looks for, do the measures add up to 180? So I'm thinking, does 60 plus 120 equal 180? Yes. So the angles are supplementary. Our next angle pair are vertical angles. Right? Vertical angles are two non-adjacent angles formed by intersecting lines. So in this picture here, we need to draw two lines intersecting. Put some letters in. And what we got to be mindful here is where are vertical angles? So they're not adjacent to each other. So this angle here, angle ABE and angle CBD are vertical angles. That's not the only vertical angle pair here. We've got another set here in blue. So we've got this angle and this one. So angle ABC and angle EBD are vertical angles. Which then leads us to another rule, another theorem, right? The vertical angle theorem, which gets abbreviated as VAT. If two angles are vertical angles, then they are congruent. Let's take a look at this next example. What's the measure of angle 1 and the measure of angle 2? Right. So in this picture, I have two intersecting lines, segments. I can immediately identify then where are my vertical angles. So here's a vertical pair, and here's another vertical pair. Right. Now remember, those vertical angles are equal. So we can mark them equal to each other. Right. That immediately tells us then the measure of angle 1 should be equal to that 18 degrees. To get the measure of angle 2, I'm going to look at this angle pair. Right. Those aren't vertical. They're adjacent, right, because they share a side and they share a corner. And the sides they don't share make a straight line. That makes them a linear pair. So the 18 plus the measure of angle 2 will add up to 180 degrees because of the linear pair postulate. And when I solve that equation, we get the measure of angle 2. All right, so in this picture, we've got a couple different measurements here going on, and a lot of different ways that we can solve this. You have to be able to find angle pairs with what I call a lot of noise within the picture. So not only is there two lines, there's actually three lines here crossing. All right, so I'm going to solve for x first, and when I take a look at x, the two angles that have x we'll focus in on this line and this one. Because we can see then this is a vertical angle pair with this angle. So since they're vertical, by the vertical angles theorem, we can say they're equal. So once we've got our equation set up, we can solve for x. Now to get our y, we're going to have to realize, one, that these three angles are supplementary. They will add up to be 180 degrees. Okay. So let's write that out. So there's our algebraic setup. Now we use algebra and solve for y here, right? One step at a time. Y turns out to be 3 and x is 4. In closing, I want to make sure that you come up with your own compare and contrast a linear pair versus supplementary angles. So if I were to summarize this in a different way, can you tell me what do linear pairs and supplementary angles have in common and what don't they have in common?